Welcome to the grand finale of our ionization journey. We've learned how to spray molecules, how to burn them, and how to hit them with kinetic wrecking balls. But today, we master the most elegant force of all, light. Imagine launching a fragile glass skyscraper into orbit. Direct force shatters it. But what if the entire foundation was an explosive cushion? That is MALDI. Today, we give wings to molecular titans, weighing hundreds of thousands of Daltons. Direct laser desorption failed for decades on large molecules because light snaps bonds. With matrix-assisted technology, we move from thermal destruction to photonic acceleration. We use a "sacrificial buffer" to absorb the violence of the light, allowing the analyte to glide into the gas phase intact. We aren't fighting the laser, we are leveraging it through a smarter interface. To master this gold standard technique, we navigate 4 strategic sectors. Sector A, the matrix shield, the sacrificial hero. Sector B, the nanosecond kick, explosive desorption physics. Sector C, the proton dance, how ions are born in the plume. And Sector D, the ROI of MALDI, from identifying bacteria in minutes to spatial tissue imaging. Let's look at the bouncer guarding our analytes. Why not hit the protein directly? Because the energy is too localized. A pro knows the matrix is the converter. We use a 1,000-fold excess of organic acids like CHCA or DHB. Look at the ratio on screen. For cytochrome C, we use ** 4,000 to 1. These molecules vibrate violently and protect the giant in their midst. They take the hit so the protein doesn't have to. Ever wonder why your signal disappears? It's all about the softness and absorption. Mentor's tip: use CHCA for sharp kicks for peptides. Move to synapinic acid for massive 100 kDa proteins. If you're working with sugars, DHB is your friend. A specialist doesn't just prepare a sample, they architect the crystal lattice to match the weight of the target. Chapter B, the nanosecond kick. When the 337 nanometers laser fires, it delivers a massive energy in a heartbeat. Imagine the floor turning into a high-speed trampoline for 10 nanoseconds. The matrix sublimates, creating a supersonic plume. This gas carries massive analytes from solid to gas phase before they even realize they've been hit. High-speed physics for high-stakes biology. Now the molecule is airborne, but neutral. In the dense plume, matrix molecules are excited and acidic. They donate a proton to the analyte. Unlike ESI's forest of multiple charges, MALDI almost always gives a single charge. It's a clean handoff in midair. 1 peak per molecule. No math, just identity. That is the strategic simplicity of the proton dance. What if the dance isn't efficient? Enter MALDI2. We fire a second laser into the expanding plume. This re-excites the molecules, boosting signal by up to 3 orders of magnitude for lipids. It reduces the analyte suppression effect and lets you see what was hiding in the dark. It's the ultimate gain control for the photonic catapult. We choose MALDI for speed and mass. In clinical microbiology, the biotyper revolutionized diagnostics. But the crown jewel is MALDI imaging. Pixel by pixel, we map drug localization in tissue sections. It turns a sample into a chemical photograph, mass spec with a spatial address. It is high-throughput forensics at the tissue level. Have you ever felt a project was too big to move? MALDI teaches us you don't need a bigger hammer. You need a smarter buffer. By letting the matrix handle the violence, we enable the impossible. We've stopped trying to boil the ocean and started using the photonic elevator. This is how you move from a technician to a structural architect capturing the architecture of life. Summary: the power of the plume. We've mastered the shield, the nanosecond kick of the 337 nanometers laser, and the proton dance. Remember, don't fight the laser. Light is the gentlest way to lift a giant. You now have the full toolkit to analyze the molecular titans. Carry this photonic efficiency back to your bench and launch your data to new heights. We've mastered ion creation. But now comes the most important question. How do we sort them? Join me in Module 7-1, where we master the logic of the quadrupole. We move from making ions to strategic sorting. Any final questions on the photonic catapult before we head to the gates of the analyzer? I'll see you in the mass filter.